In this segment, we're going to talk about quality. And quality is the property that allows us to describe the proportion of saturated vapor in a two-phase mixture of saturated vapor and saturated liquid. So let's look at a video, and we're going to look at a constant pressure phase change from a compressed liquid to a superheated vapor. We're going to look at this process on a TV diagram, and we're also going to visualize it with this liquid water in a piston cylinder. So it's liquid water, and we're going to watch it undergo a constant pressure phase change to a superheated vapor. So let's watch it. So we're adding energy. It looks like we're adding energy in the form of heat, and this is a constant pressure process. So it follows a line of constant pressure from the compressed region to the saturated liquid line. And during that particular part of the process, all the water exists in a liquid form. And then as soon as it crosses over that saturated line into the two-phase region, you start to see bubbles. You start to see, they have it written as water vapor here, but it's specifically saturated water vapor and saturated liquid water. So you've got a proportion of both of those within that two-phase mixture. And the other thing that you'll notice is because it's a constant pressure process in the two-phase region, it's also a constant temperature process in the two-phase region. So it's going to go all the way across, it's going to hit that saturated vapor line, and you'll have 100% water vapor, you'll have 100% gas, and then it continues on into the superheated region. Quality is the property that describes the proportion of those things, and it's an intensive property. And it's also independent of temperature, pressure, and specific volume. So if you know quality and you know one of those things, that's two independent intensive properties, that would be enough to fix your state for a simple compressible system. So let's look at this on a TV diagram, and we're going to look specifically at the change from a saturated liquid to a saturated vapor. So saturated liquid, saturated vapor. This is a constant pressure process and a constant temperature process, and you saw that on the previous animation. And as we go from the saturated liquid line to the saturated vapor line, you see water vapor appear. So you see saturated water vapor appear, and you start to see the amount or the ratio of the saturated liquid water to saturated water vapor. You start to see that decrease. So the liquid portion decreases, the gas portion increases. Quality, which is X, is the property that we use to describe that. So it's defined as the mass of the saturated vapor, M sub G, over the total mass, the mass of the saturated liquid plus the mass of the saturated vapor. And sometimes we just write that denominator as M. It's just the mass of the water, the mass of everything put together, those two components together. So the quality can have a value from 0 to 1. If it's a saturated liquid water, or if it's a saturated liquid, if it's on that saturated liquid line, you have 100% of that phase is liquid, and so you don't have any saturated vapor. So your quality would be 0. And as you move across, it increases all the way until it gets to a maximum quality of 1 or 100%. You can express it as 100% as a percent as well, all the way till it gets to that saturated vapor line. So if it's on a saturated vapor line, you have a quality of 1. And you can use that quality to calculate what your specific volume is. So remember, on your saturated tables, you've got a column for V sub F and V sub G. Well, you can use that quality to calculate what the specific volume is of the overall two-phase mixture. And it's sort of a weighted average of that V sub F and V sub G value. You can also write that difference V sub G minus V sub F as V sub FG. Some tables will have a column for that. Yours doesn't, but some tables do, so just be aware of that. Also be aware that quality is only defined in that saturated region. So it's incorrect to say that a compressed liquid has a quality of 0. yes, it's true that it doesn't have there's no saturated vapor, so m sub g is 0, but the denominator of that quality equation is also undefined because you don't have any saturated vapor or saturated liquid. So only in the two-phase region. If you're given a quality, you're in the saturated region. So let's work a problem. What's the temperature and quality of water at 10 kilopascals and 10 meters cubed per kilogram? So I'm going to write things as given, find, assumption, solution. I went ahead and converted my pressure to 0.1 bar because my tables are written in terms of bar. First thing I need to do is figure out what phase my water is in at that pressure and specific volume. I kind of have a hunch that it's probably saturated because I was asked to find the quality, but who knows, that could have been a trick question. So I want to make sure that I do actually have a two-phase mixture. So I pull up my saturated tables that are organized by pressure, and I just go to the line corresponding to 0.1 bar. And I see that my specific volume, 10 meters cubed per kilogram, is between V sub F and V sub G at 0.1 bar. So I have to be saturated. And that also means that at 0.1 bar, there's only one possible temperature that I could be at, and that would be my saturation temperature, which is 45.81 degrees Celsius. And now I just have to figure out what my quality is. Might as well just use that equation that I just learned. And I'm going to rearrange that so that I can calculate X, my quality, plug in the numbers. So 10 is 10 meters cubed per kilogram. That's the specific volume that I was given. And then the other values are the V sub F and the V sub G values. You'll notice that I didn't write any units because the meters cubed per kilogram on the top and the bottom just cancel out. And I calculate 0.681, or I could put that as 68.1%, and that's okay. All right, well, let me know if you have any questions, and thank you for watching.